Okay, guys, so this is a second problem, also a free response problem, pretty much same as the last one, but except I added another uh, force vector F3 right here, and the value is much larger, okay? But they pretty much ask the same question. Like the first one, determine the resultant force produced by point at A. So A is right here, this one, okay? So for last problem, this was A, but for this problem, A is right here, okay? So it's not about the origin anymore. First thing, what I have to do, find out what the position vector is. O at the origin, of 0, and then A, uh, 0 0.3, 0 0.4, 0. B, same thing, 0 0.3, 0 0.4, and negative 0 0.2, okay? And then I have to determine MA equal to R cross F. What's my R, what's my F? Okay, so for F, we know that if it gives you more than one vector, then the R F is simply just the resultant vector of them. And then for my R, so for R, we know that it's from the point where you generate the moment to the point where the force acting, we generate the moment at A, right? Where the force is acting at B, right? So MAB, FAB, I mean RAB. My RAB, simply just B minus A, 0, so 0 0.3 minus 3, 0 0.3, 0, 0, negative 0 0.2. And what my FR is, I'm gonna put my FR right here. FR, 300 plus 330 plus 220, that's 850. Minus negative 2110. Negative 210 minus negative 240 minus negative 260. That's 710. And then 150 plus 155 plus 170. That's 475. This is my FR. Okay, so I have enough all the information I need to find out what MA is. MA equal to I, J, K. Okay, RAB 0, 0, negative 0 0.2. FR 850, negative 710, 475. All right. Okay. I'm gonna write it out. For I, it's 0 multiplied by 475 minus negative 0.2 multiplied by negative 710. I mean 710. I don't know why I'm saying 710. Okay. I. Okay. For J, don't put a plus sign. Put a negative sign in front of J. This is minus. Okay, because there's always a negative sign in front of the J. For J, 0 multiplied by 475. Zero multiplied by 475 minus negative 0 0.2 multiplied by 850 J plus my K component K, so it's going to be 0 multiplied by negative 710 minus 0 multiplied by 850, and this whole thing just go to 0 because it's multiplied by 0. Okay, so find out what my I or my J is. So MA equal to, if I input all these in calculator, I got MA equal to negative 142 I minus 170 J, but 0K. So this is my final answer. Okay, final answer for part A. I'm gonna scale it down to part B. So basically the same thing as the previous problem, but just give you guys another, just give you guys more practice on it. Okay. Label this part A. Part B, it asks determine the magnitude and the coordinate direction angle for the moment of F1 about the origin. So last previous problem is how you to find out the magnitude and the coordinate direction angle for part A, but this one is different. It's how you to find the magnitude in the coordinate direction angle for the moment of F1 about point origin O. So I'm gonna do is about, we know that we want to generate the moment at origin, so MO equal to what my R is cross product F1, okay? Because they tell you about moment about the F1, so they give you which force you're gonna use, and then I'm gonna find my R. So what my R is that it says about the origin O, so I want to find the point where generating moment to where the force is, which is ROB. Okay, so I'm going to use that ROB. Okay, and from here on, it's very simple. ROB equal to E minus O, so 0.4 negative 0.2. Okay, my F1 300I minus 210J plus 150K. Okay, then my I, J, K. I know, guys, I look a little bit rushing right now because there's just so many problems that we have to go through today. So just want to get it done. Okay. M not. So to find I, J, and K. So for I, 0.4 multiplied by 150 minus negative 0.2 multiplied by 210 I minus the J. You know, I'm going to scale this down because I write too big. For J, so 0.3 multiplied by 150 minus negative 0.2 multiplied by 300 J plus K 0.3 multiplied by negative 210 minus 0.4 multiplied by 300. Okay, and then putting in the calculator, I got MO equal to 18I plus minus 150J minus 183K. Okay, and then I have the moment at the origin in continuous vector form. So but the question asks to put in the magnetic form. So what I'm gonna do just square them, take a square root of them. So I got my M equal to 211.75. What's the unit is Newton meter. Okay. All right. So this is that. And then I have to find out what my alpha, beta, and gamma is. Okay. So my alpha, beta, gamma, cosine inverse, cosine inverse, cosine inverse. That's going to be for alpha 18 divided by 211.75. I know all of them is going to be divided by 211.75. My beta negative 105 divided by 211.75. My gamma negative 183. If I put in the calculator, I actually don't have this one worked out. Let me see what they're equal to. Give me 1 second. Oh, okay, never mind. I have this right now. So it's alpha is 85.123. Beta is 119.726. And then gamma is 149.79. Okay, so this is the answer for that. Okay, all right, part A done, part B done. Let's move on to part C. Part C. Part C says determine the magnitude of the moment of resultant force upon an axis extended between O and A. Same as the last one. Last one about the moment of axis between D and B, right? Okay. This one about O and A. So I know that M OA equals the unit vector of OA multiply by R cross F. F, we know that's going to be the FR, and then R between O and A. Okay, so I know that my force is at B between O and A. So either O to B or A to B. Pick either one, it works. So for this one, I choose O to B. So I have to find out what my ROB is. My ROB. So B minus O, it's basically just a 0 0.3, 0 0.4, negative 0 0.2. And my UOA. So I have to find out what my ROA is. ROA, and 0 0.3, 0 0.40. Magnitude of ROA is 0 0.5. Okay, guys, the last one just 0K. Okay, so I have to find out what my UOA is. UOA, so it's going to be 0.6I plus 0.8J plus 0K. Okay, I have my UOA, I have my ROB, I know what my FR is. Then I'm just going to do my moment. M equals to MOA equal to I hat, J hat, K hat. We know that first row, we have to put the unit vector UOA, so it's 0 0.6, 0 0.8, 0. Second row, ROB, 0 0.3, 0 0.4, negative 0 0.2. Last row, FR. Let me go back to see what my FR is. Okay, 850, negative 710, 475. Okay, all right, let's do MOA. We know that we can ignore K because it has a coefficient of 0 in front of it. So even if we do all cross F for K, the result, the final answer is going to be 0 for K. Okay, so I'm not going to worry about K. Let's do I first. So I. Okay. So for my I, coefficient is 0 0.6 and 0 0.4 multiplied by 475 minus negative 0 0.2 multiplied by 710. This is I. And then negative sign in front of K, in front of the J. It's 0 0.8. 0 0.3 multiplied by 475 minus negative 0 0.2 multiplied by 850. Yeah, and then plus 0 for K. Okay, and then just put everything in the calculator. I'm gonna get my final answer as negative 22, negative 221.2, and the unit is millimeter. Yeah, millimeter. So okay, answer for C. Then part D. Determine the angle between F2 and F3. Okay, so this time is for F2 and F3. Between 2 and 3. Okay, so of theta equals cosine inverse of F2 vector multiplied by F3 vector divided by magnitude of F2 multiplied by magnitude of F3. Okay, so what my F2 is, and my F2 is 330I minus 240J plus 155K. F3 equals to 220I minus 260J plus 170K. Okay, and the magnitude of F2, I got 436.49, and for F3, I got 380.657. Okay, then put them in. So 330 multiplied by 220 plus negative 240 multiplied by negative 260 plus 155 multiplied by 170 divided by 436.49 multiplied by 380.657. And my final answer for theta, I got 13.81. Okay, so this is the answer for that. All right. Okay, guys. So this is all we did for free response problems, and he's gonna ask you guys something like that. So went back and practice on moment about a point, moment about a axis, and also the angle between them. Okay. So keep practicing on that, and then we'll be going on to our multiple choice problems right now.